Okay, in this question, this is an application of linear models coming from section 1.2 in College Algebra by Lyell. This is question 21 on page 99. Now, a lot of people have trouble with what we call word problems, and what you have to realize is that all problems that come in real life actually come in the form of words, and it's our job to translate those words into mathematical symbols and equations. An equation models a particular situation. So sometimes you'll have to read this over and over until you're absolutely sure what it is that the question is asking. So let's go through and underline the things that are important. David gets to work in 20 minutes when he drives his car. Riding his bike by the same route, he takes 45 minutes. His average driving speed is 4.5 miles per hour greater than his average speed on his bike. Now here's the question. How far does he travel to work? Now this is what we call a motion problem, because it involves speed or a rate, okay? It involves time, and it involves a distance. And for a motion problem, we need to keep in mind the following relationships. The distance travelled, d, is equal to the rate times the time. For example, if you're travelling at 60 miles per hour, for 2 hours you would travel 120 miles. So also we could write this as the rate being the distance over the time, or we could write the time as the distance over the rate. Right, those three relationships are really the same. Right, now the words give you a key on what you need to use as a variable and what it is you need to find. You need to find how far, so you're looking for the distance. Let's keep that in mind. Distance is the thing that we want to know. Okay? Now, the thing that we do know is this, that his average driving speed is 4.5 miles per hour greater than his average speed on his bike. So notice that the average speed, driving, is in terms of the average speed on his bike. So that gives us a clue as to saying let x equal the average speed on the bike. Okay. All right. Now, this means that the average speed on his driving speed is 4.5 miles per hour greater than that. So x plus 4.5 is equal to the average. That's the way we write everything out. Average speed, okay, in the car. Now, you should always organise your information here, and in this case we're going to organise it in a table. So notice that because it's a motion problem, we need these three things. We need D, and I think we probably put D last since that's what we want to find. So let's put the rate, the time, and the distance. Okay, now he is going to be driving, and he's going to be on the bike. Okay, so let's look at the rates. Right, driving rate is x plus 4.5, and of course x will be the rate on the bike. That's what we called this. Now the time. Now he gets to work in 20 minutes when he drives. Now be very careful here. We have miles per hour and we have 20 minutes. So we should have the same units, so instead of minutes we should have hours, so that's 1/3 of an hour. Okay. So this will be 1/3 of an hour. Right, now when he is on his bike, it takes 45 minutes, and 45 minutes is 3/4 of an hour. Now, what's the distance travelled? Well, the distance travelled is the rate times the time. So in this case, it's going to be 1/3, which is the time, times the rate, which is x plus 4.5. And this one is 3/4 times x. Now you'll notice a very important thing here. He's going on the same route regardless of whether he's riding his bike or going in the car. This means he is travelling the same distance. So these must be equal. Alright, so this allows us to write out a linear model or equation for this particular problem. And so there is our linear equation for this particular word problem. Now what we do is we look for a common denominator between 3 and 4, and of course that will be 12. So to get rid of the fractions, we're going to multiply both sides by 12. Here, and we're going to have 12 times 3/4 x here. Notice both sides. Now 3's and 12 go 4, so I'm going to be left with 4 by x plus 4.5, which is going to be 4's and 12 go 3, 3's are 9. So we're left with this. Okay. Now we shouldn't have decimals mixed up with fractions, so I'm going to change this to 9 on 2, which is 4.5. And when I distribute here, I get 4x plus, now 2's into 4 go 2, so 9 2's are 18. And if I subtract 4x from both sides, this will imply that I end up with 18 equals 5x. Or x is equal to 18 on 5. Alright, and that will be, x is of course the rate of speed of the bike, so this will be miles per hour. Okay, so that's about 3.6 miles per hour. Now remember, don't lose sight of the fact that we're trying to find the distance here. Now remember, the distance is equal to the rate times the time. So this will imply that the distance is equal to, now our rate is 18 on 5, and we need to multiply it by the time. Now we're talking about x being the bike. Okay, notice it's the bike, and the bike time was 1/3 hour. Sorry, 45 minutes I should say, that was driving, so 45 minutes, alright, for the bike ride, so that would be 3/4. Okay, so let's see if we can solve this, and this will come out to be, let's see, this will be 2's, that'll be 9 here, and this will be a 2 here, so this will be 27 on 10, which of course is 2.7 miles, and that's the distance that David has to go to work.